Hello, am I audible?
Yes, sir.
So in last class, we have derived up to this part, that is thermal kinetic energy or kinetic energy due to temperature. So related to this part, kinetic energy equals to 3 by 2 times kb into T. Kb is constant. So on changing temperature, thermal kinetic energy of particle will change. So you will be asked to define absolute zero or simply 0 Kelvin. You must have learned about it in your chemistry as well. Do you have any idea what do you mean by absolute zero? Samira?
Uh, Sir, I don't remember.
Okay. Suppose if you put the value of temperature to be zero in the above expression, what you will get? Average kinetic energy becomes zero. Is it clear?
Yes, sir.
It means there is no movement of particle at this particular temperature, or you would say randomness of gas get stopped. So absolute zero may define as the temperature at which randomness of gas get stopped. If there is no movement of gas, then there will be no existence of volume, and consequently, there will be no existence of matter as well. So 0 Kelvin or absolute zero is the temperature at which there is no existence of matter. Okay.
Yes, sir.
Now, related to this, we may have to define distribution theory or law of equipartition of energy. In this term, we have two different parts. First is equi and second is partition. Equi means equal and partition means division or simply distribution. So it states the total energy of gas get equally distributed along its all degree of freedom. Is it clear?
Yes, sir.
So in above part, we have just derived thermal kinetic energy due to monoatomic gas. So tell me the number of degree of freedom for monoatomic gas.
3.
Good. So if we distribute the above energy into 3 equal halves, kinetic energy equals to 3 by 2 kBT. And since for monoatomic, number of degree of freedom is 3, all are translational. So if you divide this particular energy into 3 equal parts, in each part, you will get energy half kBT, half kBT, and half kBT. Now from this part, we can say at constant temperature, energy in a particular particle along any degree of freedom will equals to half kBT. And since temperature is constant, Boltzmann's constant is also constant. So this energy will be always constant. Is it clear?
Yes, sir.
So according to law of equipartition of energy, state the total energy of gas get equally distributed along its all degree of freedom. And at constant temperature, energy in any 1 degree of freedom will equals to half kBt, and it will be constant. Samara, is it clear?
Yes, sir, clear.
I think you have written up to this part.
Yes, I have written. Only last point is left.
Okay.
Done, sir.
So related to this concept, we may define for F number of degree of freedom. So total internal energy in gaseous particle will be U equals to F number of degree of freedom, and along each degree of freedom, energy will be half kBt. And suppose we are calculating for n number of particles, so multiplied by n. Since number of moles equals to number of particles divided by Avogadro number, so number of particles equals to number of moles multiplied by Avogadro's number. So if you put this expression, this part, you will get U equals to F by 2 Na multiplied by N times Kb into T. This quantity, Na into Kb, is also called universal gas constant. According to this relation, Kb equals to R by Na. So R equals to Kb multiplied by Na. So if you put this expression in this part, you will get N F times R into T divided by 2. This will be total internal energy of gas at that given temperature. Samara, is it clear?
Yes, sir.
Okay. Now, related to this part, you will be asked a question. First, write it down.
Done, sir.
In 4-gram hydrogen gas at temperature 1 to 7 degrees Celsius, find first number of moles, then number of molecule, number of degree of freedom in total, kinetic energy due to translational part, kinetic energy due to rotational degree of freedom, and total internal energy. Let me define you these last two parts, how to calculate translational kinetic energy and rotational kinetic energy. Since hydrogen gas, it exists as diatomic like this. So it will have 3 translational degree of freedom and 2 rotational degree of freedom due to its translational motion and rotational motion along these different axes. So it may move along this axis, this axis, this axis due to its translational part. So total energy due to its translation will be number of moles, number of degree of freedom due to translational divided by 2 universal gas constant multiplied by temperature. Is it clear?
Yes, sir.
Similarly, how many number of particle, how many degree of freedom along rotational? So it will be 1 along this direction and 1 along this axis. So it will have 2 rotational degree of freedom. So number of moles, number of degree of freedom due to rotational part divided by 2 R into T. Now, if you add these two energy, you will get total internal energy, that is kinetic energy due to translational and kinetic energy due to rotational. Samara, any doubt?
No, sir.
Try to solve. Arslan, you may take screenshot. We have started from this part. Just take a screenshot. Arslan, done? This. Then try to find these different parts. Aslan, any problem while solving? For first part, you may use number of moles equals to given mass by molar mass. You have given mass 4 gram and hydrogen exists as H2 molecule for this state. So its molecular mass will be 2. For this 2 term, try to find number of moles. Then again, for number of particle or number of molecule, you may use number of moles equals to number of particle divided by Avogadro number. On solving, you will get number of molecule. Try to find. Samara, how to calculate number of degree of freedom?
So by the formula you gave before.
Okay. In this part, we have 3 translational and 2 rotational. So in total, we have number of degree of freedom for this molecule is
5.
5. And this particular 5 molecule, or 5 number of degree of freedom is only for just one molecule. And how many molecule do you have in this whole mass?
2.
In number of, no, 2 is number of moles. So in second part, you have calculated number of particles or number of molecule, that is 12.044 10 to the power 23. Okay.
Okay, sir.
The total degree of freedom related to this part will be 5 times number of molecule. Is it clear?
Yes, sir.
Arslan, we have in this question given mass 4 gram, and since it's for hydrogen gas, so its molecular mass will be 2. So number of moles related to this part will be given mass divided by molecular mass, that is 2 moles. Arslan, is it clear? So number of particle will equals to number of moles multiplied by Avogadro number, which is equals to 6.022 into 10 to the power 23. So it will be equals to 12.044 into 10 to the power 23 molecule. Arslan, is it clear? Good, Samira. Okay. Now in third part, total degree of freedom will be 5 times number of molecule, which will be 2 into 6.022 into 10 to the power 23. 2 into 5, 10. So it will be 6.022 into 10 to the power 24, or you may write 60.22 in 10 to the power 23. So this will be total degree of freedom in this entire sample. Similarly, try to put these terms and simplify it. In third part, Samira, just tell me number of moles.
2.
Number of translational degree of freedom for this part.
3.
3. Divide by 2. R is universal gas constant, which is equals to 8.314. And temperature is 120 degrees Celsius, 127. So convert into Kelvin, it will be 400 Kelvin. So this will be total amount of energy in Joule. Similarly, in next part, number of moles is 2. Number of rotational degree of freedom, 2 divided by 2. R, 8.314 multiplied by temperature, 400 Kelvin. So it will be total rotational kinetic energy. Now just add these two terms. You will get 2 multiplied by 5 by 2 into 8.314 multiplied by 400 Joule. Samira, any doubt?
No, sir.
Okay. Arslan, is it clear? Okay. So this will be your final answer.
Done, sir.
Arslan, done? Now, next relation is velocity of gas. In general, we may define velocity of gas in 3 different ways. Suppose if velocity is given in tabular form, like velocity of gas by number of particle or gaseous particle moving with that much velocity. Let's say V1 velocity having F1 number of particle, V2 velocity having F2 number of particle, and so on. Vn velocity having Fn number of particle. So using this tabular form, first we define average velocity. Average or mean velocity. So it will be equals to sum of observation divided by number of observation. So it will be equals to summation Fi Vi divided by summation Fi. But if you define it for whole volume, which having some pressure, temperature, so it will be equals to root under 8 by pi r into t divided by capital M, which will be equals to 8 by pi in terms of kb divided by small m, and it will be equals to root under 8 by pi p divided by rho, where capital M is molecular mass, small m is given mass, kb is Boltzmann constant, p is pressure, and rho is density. Samira, is it clear?
Yes, sir.
Similarly, the next part is most probable speed. In class 10th or 9th, you must have learned about how to calculate or what do you mean by mode in a statistic part of mathematics. Samira, any idea how to calculate mode or what do you mean by mode?
Sir, don't know.
The data which having maximum repetition or maximum frequency is termed as mode. Similarly, in this part, the velocity with which maximum number of particles moving with is termed as most probable speed. Is it clear?
Yes,
So
sir.
Vmp is velocity with which maximum particle moving with. So for whole volume, it will be equals to 2RT divided by M, 2 kBT divided by small m, or simply 2p by rho root under. The last part, a more generalized, that is root mean square velocity. Root mean square velocity of gas, or simply VRMS. It is equals to sum of FI square, means sum of observation by taking its square, divide by number of observation. So it will define square mean velocity. So if you take a root under of this whole part, it will be termed as RMS velocity. For whole volume, it will be equals to 3RT divided by M equals to 3 times kBT divided by small m equals to 3p by rho root under. Samira, any doubt?
Sir, where did this 3 and 2 come from?
Okay. The above part, you have to just remember it and nothing more. In third part, you have to derive it according to the above relation for pressure exerted. Like we had P is equals to 1 by 3 rho V bar squared. So V bar is square mean velocity. So V bar square equals to 3p by rho. Now take a square root of both sides, this part and this part. Initially, it was square mean velocity. Now it has under root over it. So it will be termed as root mean square velocity. Is it clear?
Yes, sir.
So for your course, only you have to derive this RMS velocity. Rest of the time, you have to just remember and nothing more. So for this part, you'll be just asked to arrange these terms in ascending order or descending order. Now, on the basis of these values, you'll be asked to calculate only RMS part. Okay,
Okay, sir.
just write it down.
Done, sir.
Aslan, done? Okay. Now, from where we derive these different terms, so it is basically result of Maxwell distribution of gas or velocity of gas. So for this part, you'll be asked to arrange these different velocity in ascending or descending order. So how to arrange them? Just remember RAM. First word is R, it means RMS velocity. Second word is A, means average velocity, and third word is M, that is most probable speed. So RMS will be maximum, then average, and least will be most probable speed. Is it clear?
Yes, sir.
Next, according to Maxwell distribution of speed of gas. Actually, the above all result word is to Maxwell according to this particular graph. In this part, this vertical line or y-axis will be number of particles dn over dv, fractional number of particle having this much amount of velocity. So related to this part, graph will be like this. It means the tip part will be velocity or the number of particles or the maximum number of particles moving with this velocity. So it will be termed as most probable speed. So it will be most probable speed. Adjacent to it, this one, it will be segment for V average. and then adjacent to it, RMS velocity. So this is the relation of number of particles moving with that much velocity. So from this part, you will say there in a particular sample of gas, there will be maximum number of particles which having VMP velocity, then lesser than that, average velocity, and the least number of particles must be moving with RMS velocity. Is it clear?
So can you repeat again?
From this relation, we have highest or maximum number of particles with which or particle moving with VMP velocity. So in a particular sample, you will be asked with which velocity or with which velocity most particles will moving with. So you will say VMP. The next adjacent to it will be average velocity, and there will be least number of particles in sample must be moving with RMS velocity. Suppose if you have 100 particles in a particular sample, okay? So 60 particles must be moving with V1 velocity. Let's say 30 particles moving with V2 velocity and 10 particles moving with V3 velocity. So what will be V1, V2, and V3? So you will say maximum number of particles will have VMP velocity or most probable speed. Then lesser than that will be for average velocity, and the least number of particles moving with RMS velocity. Is it clear?
Yes, sir, clear.
So this is basically arrangement on the basis of number of particles in a particular sample moving with these different velocity. So let's say N for maximum particle, then average, and then RMS velocity. Arslan, is it clear? Now there will be another curve to define its factor dependency. For this part, if we draw a vertical line at this point and vertical line to this point, so it will be, let's say, V1 and it will be, let's say, V2. Which one is more, V1 or V2?
V2.
Good. So let's say this is for M1 and M2. So in all of the above expression, like for VMP, average, RMS velocity, all velocity are directly proportional to root of temperature and inversely proportional to molecular mass. So from this part, since V2 is greater than V1, it means T2 will be greater than T1 and M2 will be smaller as compared to M1. Is it clear?
Yes, sir, clear.
So on the basis of temperature, molecular weight, they will ask by this particular diagram. Suppose they will say we have for N2 and H2. So which graph will depict N2 and which graph will depict H2? So just compare their molecular weight. You will say N2 will have large molecular weight, so it must have a smaller velocity. That will be the green curve will be for N2 and red one for H2. Is it clear?
Yes, sir.
Okay. Samaira, done? Okay. Arslan, done? Okay. Now the last part of this chapter is concept of mean free path. Suppose this is any gaseous particle. It moves this much amount of distance, get collide with this particle, get deflected along this direction. Further collision, get deflected along this direction, further along this way, and so on. So for each collision, we may define three different terms. First is, suppose this particle has traveled from this point to this point, let's say x1 distance for its first collision. In second part, x2 distance for second collision, and so on, x3 distance for this collision. So the average distance between any two successive collisions traveled by this particular particle is called mean free path. Is it clear?
Yes, sir.
So average distance traveled between two successive collision is mean free path denoted by lambda. So it will be x1, x2, so on to xn divided by number of particle or simply number of collision. Next is time taken for this first collision to happen, let's say t1. Time gap between second collision from first and second, t2. Time gap between second and third, let's say t3, and so on. Now, if we take the average of these different time gap between any two successive collision, it will define you relaxation time or frequency rate of collision. So next is relaxation time denoted by tau or average time. So it is the average time gap between successive collision. So tau or simply T average equals to T1, T2, so on to Tn divided by number of particles. It will be also called 1 by rate of collision or simply frequency of collision. Is it clear?
Yes, sir.
Now I just defined distance, time, then third is velocity. Let's say for first collision, it must moving with v1 speed, and second part moving with v2, third moving with v3. So if we take the average of these different speed of particle in this collision, it will be termed as average speed. So next is average velocity or average speed. The average of all speed in between any two successive collision. So V average equals to V1, V2, and so on to Vn, divided by number of particle or simply number of collision n. Now, mean free path is total distance or simply average distance, relaxation time or simply tau as time gap, and this average velocity speed. So according to the formula, distance equals to speed into time. We may rearrange these different terms. So mean free path equals to average velocity into relaxation time. Samira, is it clear?
Yes, sir.
Okay, just write it down.
Sir, please scroll down. Done, sir.
Arslan, done? Okay. Now using this part, we have to calculate expression of mean free path. So let me define you how to calculate. Suppose there is a gaseous particle having diameter d. So within the range of this, it may collide with any neighboring particle. Let's say there is another particle at this point. Consider gaseous particle having number density and diameter of each is d. So within this particular range, diameter of this gaseous tube is d. So radius of this cylindrical segment from this point to this point will also d. So within the range of this much volume, distance covered will be average velocity into time taken. So if you have to calculate total number of particles within this particular range or total number of collision taking place within this particular range, so let me define you how to solve. As n is number density, it will be equals to number of particle divided by volume. This number of particle also equals to number of collision. So number of collision divided by volume. So number of collision will equals to number density multiplied by volume. So in this part, cylindrical segment, volume of cylinder is pi r squared times h. So pi, radius is d squared, h, which is speed into time taken. Samira, is it clear?
So what is small n in this?
Number density, number of particle over a particular volume. So as the number of particle, or simply I'm just considering if you have n number of particle and all must be colliding, so there will be must have n number of collision as well. So the number of particles must equal to simply number of collision. Is it clear?
Yes, sir.
Now, this is number of collision in this part. So if you divide this delta t to left side, number of particle divided by time taken, it will be n pi d square multiplied by average speed. So this is also called number of collision per unit time. So it is called rate of collision. So if you take the reciprocal of this segment, time taken by number of collision, it will be termed as tau equals to 1 by n pi d square multiplied by average speed. Samara, is it clear?
Yes, sir, clear.
So if you put this expression in the above part for mean free path, so mean free path equals to average speed times tau. Tau is n pi d squared times average speed multiplied by average speed. So this part and this part will cancel out. So lambda equals to 1 by n pi d squared. But this expression is not the exact according to experimental result. So what is mistake in this particular expression? Let me define you. In above part, I have just assumed that only first particle is moving and rest of the whole gas is at rest. Like in this part, I have just assumed only first particle, this one, is moving from this point to this point, makes its first collision, then get deflected along this direction, then along this direction, and so on. In this whole part, I've just assumed that each of rest of molecule is at rest, only if this one is moving, but it will be not possible. All particles must be in motion with respect to one another. Is it clear?
Yes, sir.
So instead of taking the average speed for this particular calculation, you must have to take average of their relative velocity. Is it clear?
Yes, sir.
So in the last part, it was experimentally calculated, then defined, since all other gaseous particle must be in relative motion. Hence, it should have average of it will be better to take average of relative velocity. Therefore, The above result becomes 1 by root 2 times n pi d squared. So this root 2 introduced in this particular expression on the behalf of this average of relative velocity. Is it clear?
Yes, sir.
Just write it down. Arslan, done? Samaira, done?
No, sir. Done, sir.
Arslan, done? Okay. So this is the entire part of this kinetic theory of gas. Now in this whole chapter, you'll be asked 2 or 3 things. First, pressure exerted by gas. Second, what do you mean by absolute zero? Third, calculation of degree of freedom according to different molecule. They will give you monatomic, diatomic, triatomic, and the best of which you have to calculate number of degree of freedom. And the last part, derivation of this entire mean free path. Okay, only these 4 things you'll be asked from this chapter. Okay, any doubt, Samaira?
No, sir.
So let's start new chapter, that is simple harmonic motion or simply oscillation. So first, what do you mean by periodic motion? Any idea? Samaira? Just tell me period of rotation of Earth on its axis. How much time it will take to rotate on its axis? For spinning, it takes total 24 hours. That's why day and night combined duration will be 24 hours. That will be rotation of Earth on its axis. Good, Arslan. So similarly, we can say all different motions which occur at a particular fixed time period, or the motion for which it will have fixed time period, is called periodic motion. Samaira, is it clear?
Yes, sir.
The motion of a body having fixed time period. Suppose motion of a planet around sun, motion of satellite around planet, motion of electron around nucleus, and so on. Suppose there is a nucleus and electron is revolving around this nucleus, starting from this, going along whole path and return back to its own position. So this is called periodic motion. It takes a fixed time period to revolve complete around nucleus. Similarly, let's say a bob attached to a string is fixed to any vertical support and oscillating to and fro within this range, from this point to this point. So it will be also a periodic motion, but there is some specialty in this part. The initial position from which bob gets started is mean position, extreme position, and this is also extreme position. So what is spatial in this particular part as compared to the motion of electron? In this part, bob will oscillating about this given fixed mean position to and fro, to and fro, to and fro. So this is spatial periodic motion in which body vibrate or moves about a fixed position that is called mean position, to and fro, or up and down. This spatial periodic motion is also called simple harmonic motion. Samaira, is it clear?
Yes, sir.
So simple harmonic motion is a periodic motion in which body moves to and fro or up and down about a given fixed point that is called mean position. This periodic motion or spatial periodic motion is called simple harmonic motion, or simply SHM. First, write it down, then I'm defining with the other example of this simple harmonic motion.
Done, sir.
Just 1 minute. Okay, now to define this more clearly, what is oscillatory motion to and fro or up and down? Let me define you giving example of uniform circular motion. Uniform circular motion as SHM, simple harmonic motion. Suppose a particle is revolving around this circular path at constant angular velocity. Let's say it has started from this point. At some instant, it will be at this, and this. And next path, it will be at this point, may reach to this. Like this. So if you draw projection of these different position of particle along any diametrical axis, let's say I'm projecting its projection along x-axis. So at any instant, it will be at this point. At some other instant, it will be at this point. Then at this point, it means particle has started from this, moved along this path to reach at this point, further to reach at this end, get returned back to move along this way to move at its initial position. So if you just analyze this particular motion about its origin, So it is behaving to and fro movement about origin. Samira, is it clear?
Yes, sir.
Similarly, if you want to calculate this particular motion of projection along y-axis, if you draw a vertical projection at this point, so initially particle was at this point, so it may move along this way to reach at this point, it return back, so it is behaving to move up and down about origin. So on combination for these two different motion, we can say if a body is moving along uniform circular motion, so the motion of projection of particle along any diametrical axis will act as simple harmonic motion. Is it clear?
Yes, sir.
So in first part, motion of projection along x-axis. In second part, it is motion of projection along y-axis. So combinedly, we can say during uniform circular motion, the motion of projection of particle along any diametrical axis is called simple harmonic motion. Arslan, any doubt? Okay, just write it down. Samira, done?
No, sir. Done, sir.
Now, using this concept, we have to calculate equation of SHM. Equation of SHM. Consider a particle is revolving around the circular path at constant velocity. So initially, let's say particle is at this point. So if you draw so the inclination of this line with respect to horizontal initially, let's say is phi. At some later time, when it may have reached to this point, this is at time t equals to 0, and this is at some time t, rotating at some constant angular velocity from this point to this point, pi omega. So total angle displaced during this motion will be omega into t from this point to this point. Is it clear?
Yes, sir.
Now for this part, if you draw a vertical line and a horizontal line, this segment will define your projection along x-axis, and this segment will define your projection along y-axis. So using this particular triangle, we have to calculate its x projection and its y projection. These two projections will simply define you equation of SHM. So consider a particle having mass m is revolving along circular path of radius a at constant angular velocity omega. So using this particular triangle, if you draw a vertical line and horizontal line, this length from this point to this point will act as a radius of the circular path. This length from this point to this point as horizontal or x component. This length from this point to this point, vertical component. Total inclination from this point to this point will be theta. So theta equals to omega t plus phi as total angle from starting to that time t. Is it clear?
Yes, sir.
So in this triangle, if you take sine theta, so it will be equals to perpendicular over hypotenuse. So y equals to a times sine, and theta we have omega t plus phi. Similarly, cos theta equals to base over hypotenuse. So x equals to a times cos theta, and theta we have omega t plus phi. So both these two equations will simply define you equation of SHM. Let me define you its various other factor and meaning of these different terms. First, x and y simply defines you displacement of particle at any instant or at any time t. A is called amplitude related to SHM, or simply maximum displacement. Omega is called angular velocity or angular frequency. Knowing this, you will be able to calculate its time period or frequency. Frequency equals to 1 over time period. You must have learned about it in your earlier classes. And last part, theta, it simply defines you phase at any instant. Knowing this particular theta, you will define structure of curve related to this particular motion. That's why theta is called phase. So if you put p equals to 0, so theta naught will equals to phi. So it is called initial phase or phase at initial time t equals to 0. Arslan, any doubt? Samaira, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Arslan, done? Now, let me give you a question related to this part. If y equals to 0.05 sine pi by 4 t plus pi by 6. Using this expression, find first amplitude, second time period, third frequency, initial phase, displacement at 2 seconds. Just compare this expression to the above part, and on comparing, you'll be able to calculate these different terms. Try to solve. Just compare these two expressions and try to find Samaira. Any doubt while solving?
So can you do?
Okay, just compare what we have coefficient of this sine 0.05. So just compare in this part what we have for coefficient of this sine a. So a must equals to
0.05.
okay. Now coefficient of t we have in this part is pi by 4. So coefficient of t in this expression is omega. So you'll say omega equals to pi by 4. Is it clear?
Yes, sir.
And the last constant term we have pi by 6. And last constant term in this part is phi. So phi must equals to?
Pi by 6.
Good. So on comparing, you will say A equals to 0.05 in terms of meter. Omega is pi by 4 and phi is pi by 6. Now, omega is equals to 2 pi by t. So in place of omega, you may write 2 pi by t equals to pi by 4. So pi and pi will cancel out. So t equals to 8 seconds. Is it clear?
Yes, sir.
So what will be frequency related to this part? 1 over time period, or it will be 1 by 8 hertz, or if you simplify it, you will get 0.125 hertz. Any doubt?
No, sir.
Okay. So for every question in this part, just compare with the actual formula. And from that part, you'll be able to calculate amplitude, frequency, displacement. The last part, how to calculate displacement. So put the value of t in the above expression as 2 seconds. So this was the first part. This is the second one, third part, fourth, fifth part, y equals to 0.05 sine pi over 4 multiplied by t2 plus pi by 6. So it will become 0.05 sine pi by 4 multiplied by 2. So it will be pi by 2 plus pi by 6. And in mathematical part, I had defined you if we have sine pi by 2 plus theta, it will equals to cos theta. Similarly, in this part, we have pi by 4 plus pi by 6. So it will be equals to cos pi by 6. That means cos of 30 degree, which is equals to root 3 over 2. So Myra, is it clear?
Yes, sir. Clear.
Okay.
Done, sir.
Arslan, any doubt? Okay. Now, using this expression, you will be asked to calculate acceleration velocity. So next is velocity in SHM as displacement equals to A times sine omega t. I'm just considering initial phase to be 0 in this part. Now for this, we have displacement and we have to calculate velocity. So Samara, just tell me how to calculate velocity if you have displacement.
Displacement by, no, velocity is also displacement by time.
Good. And if displacement is any time-dependent function, then velocity equals to dx over dt, or just differentiation of displacement with respect to time. Is it clear?
Yes.
So we have to simply differentiate this particular function. So for differentiation, first check the number of function it is containing. How many functions are there in this part?
One,
One or two?
two.
Which one? Sine, that is trigonometric function, and omega t, its angle is algebraic function, and both are combined in together. So we can't separate it out. So we can say this is function of function. So for differentiation of this part, we have to first assume which one is the outermost function. So you will say sine, and the innermost of it is omega t. So first differentiate the sine part, then multiply it by differentiation of the next part. So differentiating with respect to time, dy over dt equals to a being constant, sine will be cos omega t as it is. Now differentiation of omega t, in which omega being constant, keep it outside, and differentiation of t will be just 1. Why? According to the formula, if you have x to the power n, it will be equals to n times x to the power n minus 1. Similarly, in this part, we have t to the power 1, so it will be 1t to the power 1 minus 1. That will be equals to 1t to the power 0, or simply equals to 1. Samira, is it clear?
Yes, sir.
So this is velocity equals to omega times a cos omega t. Now, if you further differentiate this part, you will get acceleration. Similarly, if you differentiate it again, dv over dt, omega a being constant, differentiation of cos, it will be minus of sine omega t, and differentiation of omega t will be just omega. So a equals to minus of omega square a sine of omega t. So this will be expression of acceleration. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Arslan, done? Okay, Samara, any doubt after this part?
No, sir.